Welcome to the deep dive. Okay, today we're plunging into something pretty remarkable. A real feat of engineering nestled high up in the Himalayas. We're talking about the Chenab rail bridge. Our goal here, as always, is to dig into the sources you've shared, pull out the really key facts, the insights, and give you a solid grasp of this incredible structure. And, why it matters so much, because this isn't just any bridge. It's actually the highest single-arch railway bridge anywhere in the world. So the big question is, how on earth do you build something like that, especially there? Let's unpack this.
It's a great question. And what's truly fascinating, I think, isn't just the sheer scale, but the audacity, maybe, building at that height in that location. So geographically, it's located between Bakal and Kauri. That's in the Riyazi district of Jammu and Kashmir, or J&K. Lengthwise, it stretches about 1.3 kilometers. But here's the real kicker, the number that just... Wow. It soars 359 meters above the Chenab riverbed.
359 meters. That's hard to even picture.
It really is. To give you some perspective, that's actually taller than the Eiffel Tower.
Taller than the Eiffel Tower, okay.
Yeah. Built over a major river in a place known for, earthquakes.
Right. Taller than the Eiffel Tower.
Yeah.
That really makes you stop and think. And it's not just the height that's setting records, is it? Looking at the structure itself, it sounds incredibly complex. You mentioned it has 17 spans.
That's right, 17 spans in total. But the main feature, the one everyone talks about, is that massive central arch. It spans 467 meters.
467 meters for the arch span alone, making it the longest of its kind, I gather.
Exactly, the longest railway bridge arch span. And what's really interesting from an engineering standpoint is how it's built. It's not just solid steel beams. The arch is made up of these large steel boxes.
Steel boxes. Okay, why do that? Why not solid steel?
Well, those steel boxes are then filled with concrete. It's a composite design.
Ah, okay. So steel and concrete.
Precisely. This gives you the best of both worlds, sort of. You get the tensile strength of steel. It handles pulling forces really well, combined with the compressive strength of concrete. Plus, the concrete helps dampen vibrations.
Right, makes it more stable.
Exactly. Much more stable and durable against wind, heavy loads, vibrations. Especially for such a huge span compared to just using steel or just concrete on its own. It's about optimizing strength and stability.
Very clever. And the bridge deck itself, how does that fit in?
So the deck, where the trains actually run, is made up of 93 separate segments.
93?
Yeah, and each one weighs around 85 tons. Prefabricated, then lifted into place.
85 tons each, lifting those at that height, over that gorge? How?
Well, that required some pretty specialized equipment. They used these massive cable cranes, some of the largest ever built for this kind of project, actually.
Custom-engineered cranes, I imagine.
Absolutely. They had to be, to lift those huge sections across the gorge with pinpoint accuracy, often in, pretty challenging weather.
Just adds another layer of difficulty.
It really does. And if we connect this back to the overall design philosophy, this bridge is built for, extreme resilience. It's designed for a lifespan of 120 years.
120 years.
And it's built to withstand incredibly high winds, up to 266 kilometers per hour.
Wow.
But maybe the most impressive part, resilience-wise, it's designed to be blast-proof.
Blast-proof.
Yes, and capable of handling the country's highest intensity earthquake forces. That's Zone V seismic forces.
Zone V earthquake forces. That sounds serious. What exactly does Zone V mean in practical terms?
It's India's highest seismic risk classification. So Zone V means the area has the highest risk of suffering severe earthquakes. Designing for Zone V means the bridge has to withstand the absolute strongest tremors anticipated for that region, based on historical data and geological surveys.
So it's not just about not collapsing, it's about remaining functional.
Ideally, yes. Maintaining structural integrity and usability even after a major seismic event or, say, an explosion, it shows an incredible commitment to safety, to durability. Especially vital in a place like the Himalayas, which is geologically very active.
Absolutely. And it's worth pointing out this wasn't just one company or one country doing this alone, was it?
No, not at all.
Here's where it gets really interesting, I think. The sheer collaboration involved. Building this thing was a huge international effort, wasn't it? You had global firms working alongside India's top institutions. We're talking about the IITs, the Indian Institutes of Technology.
Yes, IIT Delhi, IIT Roorkee. Their expertise was crucial.
And the Defense Research and Development Organization, the DRDO?
DRDO was involved too, particularly with aspects like the blast-proofing analysis.
And even the Geological Survey of India, right? To understand the ground itself.
Absolutely. GSI played a key role in assessing the foundation conditions, the seismic risks, All that fundamental geological work, it was a massive pooling of expertise. Just imagine coordinating all of that.
It's mind-boggling.
Yeah.
Which brings up an important question.
Exactly. Why? Why go to all this trouble? Such a massive, complex, expensive project in such a difficult place.
Right.
Well, the Chenab Bridge, as impressive as it is, isn't just a standalone monument. It's actually a vital piece of a much larger puzzle. It's a critical link in the Udhampur-Srinagar-Baramulla Rail Link project, the USBRL.
Okay, the USBRL project. Let's talk about that for a second. This is a huge undertaking in itself, right? Building a whole new railway line.
A massive undertaking. The goal is to connect Udhampur right through to Baramulla by rail.
And the main aim is, well, it seems obvious, but connecting the Kashmir Valley.
Precisely. Connecting the Kashmir Valley with the rest of the Indian Railways network. For the first time, really providing reliable, all-weather rail connectivity.
Which hasn't existed before.
No. Road access can be difficult, especially in winter. Rail provides a consistent link.
And beyond just the physical connection, there's a development aspect too.
Oh, definitely. That's a huge part of the rationale. The idea is to really boost development in the valley. Think about it. Easier movement of goods means farmers, artisans, they can get their products to bigger markets more efficiently.
Right, things like apples, saffron.
Exactly. Faster transport, potentially better prices. And tourism too, easier access could mean more visitors, which creates jobs in hospitality, transport, local crafts. It's intended to be a major economic driver for the region.
So the USBRL is the big picture. Connectivity, development, but achieving that meant crossing some serious natural obstacles.
Huge obstacles. The terrain is incredibly challenging. Mountains, deep gorges.
And the biggest obstacle, arguably, the one this bridge tackles head-on, is the river itself, the Chenab River.
Indeed. You can't talk about the bridge without talking about the river it spans. The Chenab is a major river, flows through both India and Pakistan. It's one of the main tributaries of the Indus River system, vital for the whole region's water supply.
Where does it actually start? Its origin?
It originates way up in the Himalayas, in Himachal Pradesh, specifically in the Lahal and Spiti district. It's formed by the confluence, the joining of two smaller streams, the Chandra and the Bhaga. They meet at a place called Tundi.
Chandra and Bhaga. So in its upper reaches, it's sometimes called the Chandrabhaga.
That's right, yes. Then it flows west into Jammu and Kashmir. It carves this deep path between the Siwalik Range to the south and the Lesser Himalayas to the north. Steep cliffs, very dramatic terrain.
And then it heads towards Pakistan.
Yes, it turns southwest, crosses into Pakistan, and eventually flows out onto the Punjab Plains. It joins the Jhelum River near Trimmu, and then the combined flow eventually meets the Sutlej River. And the Sutlej, in turn, flows into the Indus. It's a complex river system.
Quite a journey. How long is the Chenab overall?
The total length is around 974 kilometers, so about 605 miles.
And it's not just flowing through, it's used heavily.
Oh, absolutely. It feeds several important irrigation canals, especially once it reaches the plains in Pakistan and India. Supports a lot of agriculture. It's a lifeline.
And it has tributaries feeding into it along the way.
Yes, quite a few. Some of the notable ones, especially in the mountainous regions, include the Mian Nala, Sohal, Thirot, Bhut Nala, Marusudar. Ladrari is another one. These streams add to its volume as it carves through the mountains.
So dealing with that powerful river, its flow, potential erosion, plus the seismic activity. The foundation design must have been incredibly challenging.
Immense challenges, a real test of geological understanding and advanced civil engineering.
Okay, so let's try and bring this all together. What's the big takeaway here? We've looked at this bridge. It's clearly more than just steel and concrete, isn't it?
Much more. I mean, yes, it's a stunning piece of engineering, record-breaking in scale. But it represents, I think, a story of human ingenuity. It's about tackling immense natural challenges through innovation, through collaboration on a huge scale.
And it's strategically vital, connecting a region, aiming to foster development.
Exactly. It's a symbol of connectivity designed for incredible resilience against earthquakes, wind, potential threats. It really shows what's possible when that kind of expertise and, frankly, determination come together.
It really does. And it makes you think. Just consider for a moment the sheer complexity. All the different fields that had to converge. You know, geology, understanding the rock and the river, civil engineering, obviously, material science, seismology for the earthquakes, even meteorology for the wind and weather during construction. All that knowledge focused on this one point in the Himalayas. What other unseen marvels? What other feats of engineering or science are quietly shaping our world right now, maybe pushing boundaries in ways we don't even realize? Makes you wonder,